A crane is lifting a load of 1250 kg vertically at a constant speed of v meters per second. Given that the power of the crane is at a constant 20,000 watts, find the value of v. So since they're talking about power, we know that power is equals to the forward force or the driving force multiplied by the velocity. And another essential information that they've given us is that it is lifting a load at a constant speed. So constant speed means that there is no change in the speed, hence the acceleration is 0. And we can use the forces formula to find out the driving force, also known as the forward force. So the forward force is unknown minus the resistive force. So since it is moving the load vertically, which means that the downward force or the resistive force will be the weight of the load. So the mass is 1250, which means that the weight will be 1250 times 10. So it's 12,500 is equals to mass multiplied by the acceleration. So this side becomes 0 since acceleration is 0. Hence the forward force is 12,500. So now we have the value of the forward force, and we can use this and the formula for power to find out v. So we know power is 20,000 and the forward force is, or the driving force is 12,500 multiplied by the velocity. Hence v is equals to 20,000 divided by 12,500, which is 1.6. Hence we have the value of v, or the speed. Question number 2. The total mass of a cyclist and a bicycle is 75 kg. The cyclist ascends a straight hill of length 0.7 kilometers, inclined at 1.5 degrees to the horizontal. Her speed at the bottom of the hill is 10 meters per second, and at the top it is 5 meters per second. There is a resistance to motion, and the work done against the resistance as the cyclist ascends the hill is 2000 joules. The cyclist exerts a constant force of magnitude F Newton in the direction of motion. Find F. So basically in this question, F is the driving force exerted by the cyclist by his bicycle. So there are two ways to do this. We can either use the work power energy formula, or we can also find out the value of F using the forces formula. Since they've already given us the work done against the resistive force, which is part of the formula, I will use the work power energy formula, which is work done driving force is equals to the change in kinetic energy plus the change in potential energy plus the work done against the resistive force. So in the question, they've already given us the work done against resistive force as 2000 joules, and they've also given us the initial speed as well as the final speed, so we can find out the change in kinetic energy. And they've also given us the distance traveled, which is 0.7 kilometers. But if you notice that the speeds are given us as meters per second, which means that the distance traveled must also be in meters. So this is 700 meters. Now we also know that work done by the driving force is the distance traveled, which is 700 kilometers multiplied by the driving force. So which means that if we find out the change in kinetic energy and the change in potential energy, we can find out the driving force. So first let's find the change in kinetic energy. An easy formula is half multiplied by the mass, which is 75, multiplied by the final speed, which is 5 meters per second square, minus the initial speed, which is 10 squared. So this is negative 2812.5. And then we need to find out the change in potential energy. For this we will need to use trigonometry rules. So let's assume the cyclist ascends a straight hill of length 0.7 kilometers. So let's assume this is the hill and it is inclined at 1.5 degrees. Now, so this is 700 meters and it starts from the bottom of the hill. This means that this is height 1, which is 0. So this whole side must be equal to the second height. So we can use the sine function. So sine 1.5 must be equals to the perpendicular over the hypotenuse, which is 700. So sine 1.5 multiplied by 700. So change in height is 18.32. So this whole side is 18.32. Now we're going to substitute these values in this formula. So work done by the driving force is the driving force multiplied by the distance traveled is equal to the change in kinetic energy, which is negative 2812.5, plus the change in potential energy, which is the mass multiplied by 10 multiplied by 18.32. Because there is an increase in height, so this will be positive, plus the work done against resistive force, which is 2000. So this side is equals to negative 2812.5 plus 75 times 10 into plus 2000. And when we divide it by 700, we get the driving force, which is 18.46. So let's round it off to 18.5. And now let's give the final answer as a statement. So hence F is equals to 18.5 Newton. Question number 3. So a block of mass 3 kg is at rest on a rough plane inclined at 60 degrees to the horizontal. A force of magnitude 15 Newton acting up a line of greatest slope of the plane is just sufficient to prevent the block from sliding down the plane. Find the coefficient of friction between the block and the plane. So first let's analyze information that they've given us. First is that the mass is 3 kg and it is at rest, so initial speed is 0. And it is on a rough plane, which means there is friction. And let's make a diagram. So it is inclined at 60 degrees to the horizontal, which is this. So let's assume this is the block, and so there will be a downward force of the weight which we can resolve. So this is 60 degrees because this is 60 degrees. And this will be 30 cos 60 and this will be 30 sine 60, and this will be the normal reaction acting perpendicular to the plane. And then we also have a force of magnitude 15 Newton acting up a line of greatest slope. So this is the 15 Newton force pulling it upward. So they've told us that the 15 Newton force is preventing the block from sliding downwards, which means the natural direction of the movement is downwards, which means the friction will be acting in the opposite direction, which means it will be acting with the 15 Newton force. And since we know that the block is not moving, acceleration is 0. So first we're going to use the force formula, which is forward force minus resistive force is equals to ma. From this we can find out the value of friction, and then we can use that value of friction and the value of the normal reaction to find out the coefficient of friction. So in this scenario, the 15 Newton force and the force of friction is trying to move the block upwards. So we will take that as the forward force. So 15 plus the friction, and but the horizontal component of the weight is pulling it downwards in this direction. That is the resistive force. And since acceleration is 0, this side will automatically become 0. So friction must equals to 30 sine 60 minus 15. Which is 10.98. And we know that friction is equals to the coefficient of friction multiplied by the normal reaction. And from the diagram we can tell that since it is in equilibrium vertically, the normal reaction is equals to 30 cos 60. Since this is acting downwards in this vertically, and this is acting upward vertically. So 10.98 is equal to coefficient of friction multiplied by 30 cos 60, making the coefficient of friction 10.98 divided by 30 cos 60. The coefficient of friction is 0.73. 2 is equals to mu. So we can write it down. The coefficient of friction is equals to 0.732. So this is part B. The force of magnitude 15 Newton is now replaced by a force of magnitude x Newton acting up the line of greatest slope. Find the greatest value for x for which the block does not move. So again, since the block is not moving, the acceleration is 0, and we can use the forces formula again, since we will assume that the other forces acting on the block are the same except for the x Newton force. So I'll be making the diagram again. So it's inclined at 60 degrees, and when we resolve the weight, and this is the x Newton force. So they've asked us for the greatest value of x. Now when we write down the forces formula, we can tell that the greatest value of x will only be in the case when friction acts against that force. Because see, if you write it like this, forward force will be this x Newton force, and the resistive force can be the friction plus the horizontal component of the weight, since they're now both acting in the same direction, downwards. Minus 30 sine 60 is equals to 0. I've applied the forces formula here. So mass multiplied by 0, which is the acceleration, will make this side 0. So that means that x is equals to friction plus 30 sine 60. This will give us the highest value of x. If friction was acting opposite or with the force of x, this would be written as x plus friction minus 30 sine 60 is equals to 0, which would make it that x is equals to 30 sine 60 minus friction. This will give the lowest value of x. So this means since we want the greatest value of x, we will use this equation. So from the last part, we know that friction was equals to 10.98. Since the coefficient of friction and the value of r is the same, so x is equals to 30 sine 60 plus 10.98, which is 36.96. We can round it off to 3 significant figures, which makes it 37 newtons. So the greatest value of x is 37 newtons. This is question number 4. So it says 2 blocks A and B of masses 4 kg and 5 kg respectively are joined by light inextensible string. The blocks rest on a smooth plane inclined at an angle of alpha to the horizontal, where tan alpha is equal to 7/24. The string is parallel to a line of greatest slope of the plane with B above A. A force of magnitude 36 Newton acts on B, parallel to a line of greatest slope of the plane. Find the acceleration of the blocks and the tension in the string. So first, talking about this introductory paragraph that they've given us. First, they've given us the masses of both the blocks, so we need to resolve the weights. So for block B, there will be a downward pressure of the weight, and so the angle over here will always equal be to the angle over here. We can write this as 50 cos alpha and 50 sine alpha. And for block A, when we resolve the weight, this will become 40 cos alpha and this will become 40 sine alpha. This way. And then what they've given us is that they are at rest on a smooth plane. Rest means that the initial velocity is 0 and the smooth plane indicates that there is no friction. Then they've given us the value of tan alpha. Now in this question you will need to be using the value of sine alpha and cos alpha. Now we can use the rule of trigonometry to find out the exact value, the exact numerical value in fractions of both cos alpha and sine alpha. For example, this is the triangle and this is the angle alpha. So tan is always equals to the perpendicular, which is 7, over the base, which is 24 in this case. So now we can use the the Pythagoras theorem and find out this side. So 24 squared plus 7 squared. So this side is 25. So that means that sine alpha is equal to the perpendicular over the hypotenuse, so it's 7/25, and cos alpha is equal to the base over the hypotenuse, which is 24/25. So now we have the exact values of sine alpha and cos alpha, and so we know that there is a force of 36 Newton. So this is a horizontal, it's parallel to the line of greatest slope, so we do not need to resolve this. So we need to find the acceleration of the blocks and the tension in the string. We cannot find this out using the formulas of kinematics, such as v is equals to u plus at or v square minus u square is equals to 2ax, because there's a lot of unknown information that we do not know. In that case, one simple formula that we use is the forces formula, which is that forward force minus resistive force is equals to ma. Now, another important thing to realize is that they're joined by a string. So that means there will be tension in the string. This way. So for block B, the tension in the string will be a resistive force, as it will be pulling it down. However, for block A, it will be the forward force because it will be pulling it upward. So let's write it in terms for particle B. So for particle B, the forward force is the 36 Newton force, which is acting exactly on the block B. So that will be 36, and the resistive forces will be the horizontal component of the weight as well as the tension in the string. So this will be minus tension in the string minus 50 sine alpha is equals to the mass, which is 5, multiplied by the acceleration. For particle A, the same tension of the same magnitude acting on B will be the forward force, while the resistive force will be the horizontal component of the weight, which is 40 sine alpha is equals to the mass multiplied by the acceleration. Now we can simultaneously solve this. So there's minus t over here and plus t over here, so you can cancel those out. So that means that 36 minus 50 sine alpha minus 40 sine alpha is equals to 9 multiplied by the acceleration. So we have the value of sine alpha, which is 7 over 25, and we can plug it into the equation, and then we can rearrange it to find the acceleration. So this will become 36 minus 10.8 is equals to 9 times the acceleration, 1.2. Now we can substitute this value of the acceleration into any of these two equations, and we can find the tension in the string. So I'll use the equation of particle A. T minus 47 sine alpha is equals to 4 times 1.2. Tension is equals to 4 times the acceleration plus 40 times 7 over 25, which is 16 newtons. So now we have the value of both the tension in the string and the acceleration. So we can make a statement over here, which is acceleration is equals to 1.2 meters per second square, and tension in the string is equals to 16 newtons. That's part A. Part 2 states, at a particular instant the speed of the blocks is 1 meter per second. Find the time after the instant that it takes for the blocks to travel 0.65 meters. So let's write down the information that they've given us. So the initial speed is 1 and the distance traveled is 0.65 meters. So now, since there's mention of speed and distance, means that now we can use the formulas of kinematics, which we can write them down on the side to see which one is the most appropriate for the information we have. So we have v is equals to u plus at, we have v square minus u square is equals to 2ax, and then we have x is equals to ut plus half at square. So we need the time, and in the previous part we found out the acceleration of the blocks. So the acceleration was 1.2. So we can see that the third formula is the most appropriate, since we have the acceleration, the distance traveled, as well as the initial speed. So that means that 0.65 is equals to 1t plus half times 1.2 t squared. So 0.65 is equals to t plus 0.6 t squared. So we can rearrange it and write it as this, multiply both sides by 100. So and we can solve it by applying the quadratic equation. .5. Let's find out the other value just in case. So it's -2, so we'll not write it. So t is equals to 0.5. We can write this down. It takes the blocks 0.5 seconds to travel 0.65 meters from the instant the speed of the blocks is 1 meter per second. So that is the end of question number 4.